Welcome back. In this video we're going to define the determinant of an n by n matrix using a permutation definition. We begin with our n by n matrix A, which will have n rows and n columns. And just for a reminder, we write the row and column index as the first and second entry of the indices for the coefficients in this matrix. 1, 1 would be the first row, first column. A1, 1 is the coefficient in that location. A1, 2 is the coefficient in the first row and second column, and so on and so forth. So here, if it's an n by n matrix, we have n rows, 1, 2, all the way to n, and we have n columns, 1 all the way to n. We're going to use these coefficients in our definition. So here is an n by n matrix. We define the determinant of this matrix, the determinant of A, to be a sum with n factorial summands. We're going to talk about this in detail. So we sum over all permutations in the symmetric group on n elements, where we multiply each summand by the sign of the permutation, and then the product that follows is the product of the individual entries in A with a slight modification depending on each particular permutation. In this notation, this is read the determinant of matrix A, where A must be a square matrix. This sum has n factorial summands. And remember that a summand is just an individual part of the sum. This is the sign of each permutation. We call this the sign of a permutation. And then here, the first entry, we have, this is the row index. So row index 1 corresponds with the first row, and what happens is the corresponding column index, here this is the column index, comes from evaluating the row index through the permutation that we've chosen. So we start with row 1, we evaluate 1 at each particular permutation to get the column index, and we go all the way down through n. In order to understand this definition of the permutation, this definition of the determinant, we're going to evaluate this for S2, the symmetric group on 2 elements, and also S3, the symmetric group on 3 elements. So we will define both permutations for a 2 by 2 and 3 by 3 matrix. Please join me in the next video as we discuss how this formula works. See you there.